Okay, to solve this problem, rationalizing the denominator, let's first simplify this just as much as possible. And because the square root of a divided by the square root of b is always the same as the square root of a divided by b, we can combine these under one radical, which will allow us to cancel common factors. Also, 40 is 10 times 4. So I'll write as 4 times 10 x y to the fifth. And in the denominator, 3 times 10 is 30. X to the fifth times y. So now we get some cancellation happening. The 10s cancel. One of the x's cancels, and one of the y's cancels. So what we're left with is, in the numerator, 4. This x cancels, leaving x to the fourth downstairs. One of them cancels, leaving 4 instead of 5. And out of the 5 y's that are upstairs, one of them cancels, which leaves 4 y factors up there. So this is equal to the square root of 4, if we break it up, the square root of the numerator divided by the square root of the denominator. So that's the square root, well, the square root of 4y to the fourth is 2y squared. And the square root of the denominator is the square root of 3 times x squared. So all that's left in terms of radicals in the denominator is that square root of 3. So if I multiply the top and bottom by the square root of 3, the square root of 3 times the square root of 3 is just equal to 3. So in the numerator we end up with 2y squared radical 3, and in the denominator we end up with radical 3 times radical 3 is 3x squared. So there we have eliminated the radicals from the denominator. We've rationalized the denominator.